Have you ever wondered how engineers build bridges in deep water? It's quite a marvel, isn't it? It's not as simple as building a bridge on land, and it requires quite a bit of ingenuity and innovation. Today, we're going to delve into the fascinating world of bridge construction, specifically focusing on the use of caissons in the process. First, let's tackle the basics. What exactly is a caisson? In the context of bridge construction, a caisson is essentially a watertight retaining structure. It's used to work on the foundations of a bridge underwater by keeping the work environment dry. Picture a big hollow cylinder that's open at both ends. The first step in using a caisson is the design phase. Engineers need to consider various factors such as the depth of the water, the nature of the seabed, and the load the bridge will carry. Once they have this information, they can design the caisson accordingly. Next comes the construction of the caisson. This typically happens on land or in a dry dock. It's made from steel, concrete, or sometimes a combination of both. Once the caisson is constructed, it's floated or towed to the construction site. Once in place, the real work begins. The caisson is sunk down to the seabed. This is done by filling it with material like sand, gravel, or concrete. This weight pushes the caisson down until it reaches the desired depth. After the caisson is securely in place at the bottom of the sea or riverbed, the next step is excavation. The material inside the caisson is dug out, creating a kind of inverted skyscraper underwater. As they dig deeper, the pressure from the surrounding water keeps the walls of the caisson in place. Once the desired depth is reached, the final step is to fill the caisson with concrete. This creates a solid, robust foundation upon which the bridge can be built. In summary, the process of using caissons for bridge construction involves designing the caisson, constructing it, floating it to the site, sinking it to the desired depth, excavating the material inside, and finally, filling it with concrete to create a solid foundation. This intricate process allows engineers to build bridges in deep water, providing a critical link between land masses and facilitating transportation and commerce. So the next time you drive across a bridge spanning a large body of water, take a moment to appreciate the engineering marvel beneath your tires. It's a testament to human ingenuity and our relentless pursuit of progress. In our journey through the world of caissons, it's essential to understand that these ingenious constructions come in different types, each with its own unique features and applications. Firstly, we have open caissons. As their name suggests, these are open at both the top and bottom. They are typically used in projects where the soil bed is hard and solid, ensuring a secure and stable foundation. Next, we come across pneumatic caissons. These are a bit more complex. They are essentially airtight boxes with open bottoms. Workers inside these caissons operate under increased pressure, which keeps water and mud at bay while they dig. This type of caisson is often used in the construction of bridge piers and other structures in waterlogged areas. Then, we have box caissons. These are simply large concrete boxes. They're prefabricated and then placed into a dug hole. Once in place, they're filled with concrete. This type is often used in the construction of foundations for structures like lighthouses. Finally, we have monolithic caissons. These are massive single-piece structures that are cast and cured on site before being sunk into place. They are often used in the construction of massive structures like skyscrapers and large bridges. So whether it's an open, pneumatic, box, or monolithic caisson, the type used in a project depends largely on the specific requirements of the construction. Each type brings its unique strengths to the table, ensuring the best possible foundation for the structure being built. In our next segment, we'll look at some of the most impressive structures built using these fascinating engineering marvels. Stay tuned. Like any construction method, caissons have their pros and cons. Let's dive in and explore both sides of the coin. Starting with the advantages, caissons are known for their exceptional stability. Thanks to their design, they distribute the weight of the structure evenly across the foundation, reducing the risk of uneven settlement. They are also extremely versatile, being suitable for a wide range of soil conditions and construction projects. Another significant advantage of caissons is their ability to withstand lateral loads, such as wind and seismic forces, exceptionally well. This makes them a go-to choice for structures located in earthquake-prone areas or high wind locations. Caissons can also be constructed in water, making them ideal for bridges, piers, and other structures that need to be built over water bodies. Now, let's shift our focus to the disadvantages. The construction of caissons can be a complex and time-consuming process, especially for pneumatic and monolithic types. It requires specialized equipment and skilled labor, which can drive up the cost. Another challenge is the potential for health risks to workers. In the case of pneumatic caissons, workers operate under increased pressure, which can lead to decompression sickness if not managed properly. Lastly, the environmental impact cannot be overlooked. The excavation process can disturb the seabed and lead to the release of contaminants trapped in the soil, harming local aquatic life. Despite these challenges, caissons remain a popular choice for underwater construction due to their unique strengths. Understanding their advantages and disadvantages helps engineers make informed decisions, ensuring the success of their projects. Stay tuned as we continue to explore the fascinating world of caissons. Having understood the advantages and disadvantages of caissons, let's now turn our attention to some marvels of engineering, where caissons have played a pivotal role. Yes, you heard it right. Caissons have been used in the construction of some of the world's most iconic structures. Let's start our journey in the bustling city of New York, where the majestic Brooklyn Bridge stands tall. Constructed in the 19th century, the bridge's two towers were built using caissons. These were sunk into the East River's bed, providing a solid foundation that has stood the test of time. Now, let's jet off to Paris, the city of love and the home of the Eiffel Tower. This world-famous monument, renowned for its intricate iron lattice work, also utilized caissons during its construction. Deep beneath the surface, caissons were used to support the tower's massive weight, ensuring its stability. Our final stop is London, where the historic London Bridge spans the River Thames. The bridge's foundations were made secure with the help of caissons, allowing it to bear the weight of the heavy traffic it sees daily. These iconic structures stand as a testament to the effectiveness of caissons. They highlight how this construction technique, despite its challenges, has been instrumental in shaping our built environment. So the next time you marvel at these structures, remember the role of caissons in their construction. Stay with us as we continue to delve deeper into the world of civil engineering. In any construction project, safety is paramount, and caisson construction is no exception. As we delve deeper into the world of civil engineering, it's important to highlight the safety measures that are integral to the process of caisson construction. During the design phase, careful consideration is given to the size and weight of the structure it will support. The soil's composition and the water table levels are also taken into account, ensuring the caisson's stability. When we move on to the construction phase, all personnel involved are required to wear safety equipment such as helmets, safety shoes, and high-visibility jackets. The construction site is cordoned off to prevent unauthorized access, and safety barriers are erected around the excavation area to prevent accidental falls. The sinking and excavation process brings its own set of challenges. It's crucial to maintain continuous air supply for the workers inside the caisson during this phase. Regular checks are performed to ensure the structural integrity of the caisson. Moreover, all equipment used is regularly inspected and maintained to prevent any accidents or mishaps. With these safety measures in place, caisson construction can be carried out with minimal risk. By prioritizing safety, we can continue to build marvels of engineering while ensuring the well-being of those who bring these structures to life. Stay tuned as we further explore the fascinating world of civil engineering. Welcome back. As we continue our journey into the realm of caisson construction, let's take a leap forward and envision its future. Just as technology continues to evolve, so does the field of civil engineering, offering new horizons for caisson construction. Innovations in caisson design are constantly emerging, with engineers using advanced materials and techniques to enhance their strength and durability. These innovations are paving the way for more complex and ambitious structures, pushing the boundaries of what we can achieve. The introduction of robotics into the construction industry presents exciting possibilities for caisson construction. Robots can perform tasks with a level of precision and speed that human hands can't match, reducing construction time and increasing efficiency. They can also work in conditions that may pose risks to human workers, enhancing safety measures we discussed earlier. And let's not forget the potential of caissons in space exploration. With plans underway to establish human colonies on the Moon and Mars, caissons could play a pivotal role in constructing habitats and other structures in these harsh environments. Just as they've helped us conquer the oceans, they might soon help us conquer space. The future of caisson construction is as deep and vast as the oceans they help us conquer. It's an exciting time to be in the field of civil engineering, and we can't wait to see what the future holds. Stay tuned for more insights into the fascinating world of construction and engineering.